Good morning, dear respected teachers and students. In this video, I will discuss the Lorentz gauge. First, we see history of Lorentz gauge. Lorentz work was the first summarizing shortening of the Maxwell's equations. After Maxwell himself published his paper in 1865. Now, introduction of Lorentz gauge condition. In electromagnetism, the Lorentz gauge condition or Lorentz gauge is a partial fixing of the electromagnetic vector potential. In mathematical expression, the Lorentz condition is divergence of A plus mu epsilon del phi upon del t equal to 0. Now we will describe Lorentz gauge for mathematical expression. Here Maxwell's field equation in terms of electromagnetic potential are given by delta square A minus mu epsilon del square A upon del t square minus gradient of divergence of A plus mu epsilon del phi upon del t equal to minus mu j. It is first equation, and delta square phi minus mu epsilon del square phi by del t square minus gradient of divergence of A plus mu epsilon del phi by del t equal to minus rho upon epsilon. It is second equation. The whole equation is Maxwell's field equation in terms of electromagnetic potential. Now, Lorentz condition. Divergence of A plus mu epsilon del phi upon del t equal to 0. It is equation third. Lorentz condition will impose in first equation and second equation. Here, when vector and scalar potentials satisfy this condition, then gauge is also known as Lorentz gauge. Using Lorentz condition in Maxwell field equation first and second, when we put in first equation divergence A plus mu epsilon del phi by del t, this portion will be 0 because of divergence A plus mu epsilon del phi by del t equal to 0, and also this portion will be 0. Then we get delta square A minus mu epsilon del square A upon del t square equal to minus mu j, and delta square phi minus mu epsilon del square phi by del t square equal to minus rho upon epsilon. The whole equation is fourth equation. Now, but we know that the value of mu epsilon equal to 1 upon v square, where v is the phase velocity of wave. Now, equation 4 takes the form when we apply the value of mu epsilon in fourth equation, then we get del square A minus 1 upon v square del square A upon del t square equal to minus mu j, and also del square phi minus 1 upon v square into del square phi by del t square equal to minus rho upon epsilon. This is fifth equation. Now, defining a Lambertian operator, we know that the Lambertian square equal to del square upon del x square plus del square upon del y square plus del square upon del z square minus 1 upon v square into del square upon del t square. So uh, this portion will become delta square. Then we get Lambertian square equal to delta square minus 1 upon v square into del square upon del t square. It is sixth equation. After that, equation 5 becomes Lambertian square a equal to minus mu j, Lambertian square phi equal to minus 2 upon epsilon. When we compare fifth and sixth equation, then we get the equation A and the equation B. It is equation 7. Here equation 7 are similar to Poisson equation and introduce gauge function. It is sign of gauge function. Now substituting a dash equal to a plus gradient gauge function, it becomes a equal to a dash minus gradient gauge function. And also we can write we take phi dash equal to phi minus del gauge function upon del t, then it will become phi equal to phi dash plus del gauge function upon del t. Now from the equation 3rd, that is Lorentz condition, here the Lorentz condition is divergence A plus mu epsilon del pi by del t equal to 0. Here a equal to a dash minus gradient gauge function and phi equal to phi dash plus del gradient gauge function upon del t. Value of a and the value of phi putting on equation number 3rd, then we get divergence of a dash minus gradient gauge function plus mu epsilon del upon del t phi dash plus del gauge function upon del t equal to 0. It will become divergence a dash plus mu epsilon del phi dash upon del t equal to 0 only if delta square gauge function minus mu epsilon del square gauge function upon del t square equal to 0 or Lambertian square gauge function equal to 0.